Hello, and welcome to Ensuring Reliability with Burn Rates. My name is Ajuna Kyaruzi. I work in developer relations at Datadog, and I'm very excited to be here at SLOconf with you. So I'd like to start off my presentation by going over some key terms that I'll be using to make sure that we're all on the same page. Starting with SLOs. So an SLO, or a service level objective, is a target value for a service as measured via an SLI, a service level indicator, or a given metric over a specified time window. So SLOs are a great way of indicating user happiness because usually they're picked by your product owners as the threshold of which is the expected behavior of your service by your users. So if we pick that our metric or our service level indicator is requests that complete within 500 milliseconds, we can add a target and a time window to that and say that our SLO is 99% of all requests from the past 30 days should complete within 500 milliseconds. Next, I'd like to talk about error budgets. So an error budget is the maximum amount of time that a technical system can fail without contractual consequences. This is the allowed amount of unreliability, and it's usually derived from your SLO's target percentage. It's usually 1 minus the SLO. So a 99% SLO from our previous example would mean that we have a 1% error budget. In this case, that 1% of requests from the past 30 days can take longer than 500 milliseconds. So if our requests have 1 million requests over the past 30 days, a 99% SLO will give us a budget of 10,000 errors over that period. So an error budget is different from the error rate. The error rate is the ratio of bad behavior over total behavior in a current time period. This is the real percentage of failures or bad events, generally the behavior we don't want, during the SLO window as measured by a neutral party, usually your monitoring system. So if we get 1 million requests over the past 30 days and 5,000 of them failed, your error rate is actually 0.5%. You can think of your error budget as being your maximum or your ideal error rate if we want to consume our entire error budget, which generally we do. So lastly, I'd like to define burn rates, the subject of our talk today. So a burn rate is an indication of how fast your error budget is being consumed, and it's relative to your SLO's target length. So an ideal burn rate can be considered as 1. This means that it's a consistent error rate over your SLO time period, meaning that you consume your entire SLO over the SLO's target length. If you want to calculate your burn rate, and it's usually in the current moment the error rate over the error budget. We can visualize this in a graph by defining the amount of error budget remaining over a number of days, usually for your SLO time window. So for example, I have in the top line an error budget of a burn rate of 1, which shows that our error budget will be fully consumed in the 30 days that are our SLO time window, if this rate is kept constant. A burn rate of 2 means that the error budget will be exhausted in 15 days, and a burn rate of 3 means it will be exhausted in 10 days, and so forth. Now, this graph in my earlier definition, it was about ideals. Well, we know that the rate of failures is rarely constant. So what your burn rate will actually look like is more like this graph, where there is a sharper drop in different periods. It's not consistent. So you can actually think of your burn rate as the rate of change in this graph, or the slope. Suddenly, high school math is a little bit more useful. So I'll go over more detail on how to calculate your burn rates. And don't worry, I won't go into gradients or anything. However, I'd like to discuss what we would actually want to use them for, which is alerting. So when we monitor our systems, we want to know how well it's doing, and we want to not stare at them all the time. And alerting helps us with that, and it'll let us know when things aren't going well. You might already have SLO alerts and error budget alerts that let you know when you're close to consuming all of your error budget and you might be in danger of missing your SLO target. Error budgets are commonly used as a managerial tool and usually can help you notify if you have an error budget or a positive error budget. You can continue creating new features and general product development. Whereas if you have a negative or 0 error budget, you've missed your SLO target and a focus on reliability is needed. So error budgets are very helpful in determining whether or not we should be managing our systems in what way, but usually they just give us a threshold that we will cross over if we've consumed X amount of it. They aren't very helpful in determining active instance for active instance response. You actually might be in a case where you're very close to crossing over, you're like 89% of air budget consumption, and you have a small change that just maybe it's a request that has to be repeated that knocks you over into your threshold, which in this case might be 90%. Whereas if you already had consumed some of your air budget and suddenly have a really large, fast scale outage, by the time that you get your air budget alert, you've already might be in danger of already consuming your SLO. You might have already consumed all of your air budget and have crossed your SLO target. This is where alerting on burn rates comes in handy, because they let us know the rate of change that's going on and whether there is a lot of errors in a short period of time. And it will notify us when an issue is consuming your air budget at an elevated rate that could potentially cause you to miss your SLO target. Now, when you are alerting, you need to have alerting windows. Your alerting policies need a time period for your SLO and also the time period to look back where we'll calculate your error rate. In my early examples, we actually used the entire SLO time window to calculate our burn rate. But this isn't quite helpful because we want to know recent changes, because if we're averaging over a long period of time, it'll take us a long time to find out that all of a sudden the rate in our graph or the gradient, the slope is suddenly a lot sharper than it used to be. So we defined shorter windows. We'll call these a short window and a long window that we'll look at for calculating our burn rate and alerting on it. So a short window is usually defined in minutes, and it'll let us know if there's a sudden large change in consumption that may exhaust your air budget quite quickly. A long window is usually defined in hours, and it usually catches slow but steady errors that may consume an air budget before the end of our SLO period, but it's sharper than what it used to be. So the Google SRE book has a section on alerting on SLOs, and they could recommend using different types of alerts to cover, so you have a wide range of coverage for all the different issues that might be caused in your system. In that book, they describe using definitely air budget alerts, but also different type of burn rate alerts over different windows, a long window and a short window, so that you can have optimum coverage to know if there's a longer scale incident that's happening to get alerted once and not all of the small little shorter windows, or if there's a sharp change to get alerted as quickly as possible so you can improve your time to resolution in your incidents. So Google recommends that your long window be 12 times your short window. And usually we don't want to go over 24 hours in a time period. And that might actually be shorter for a shorter SLO period. So if we want to look at your long window to be about an hour, you can actually then define your short window to be 5 minutes. Picking the right window will be determined on your SLO period, as I said. A shorter SLO period will undoubtedly have shorter windows. So next, I'd like to talk about how to calculate your burn rates. So here is a great formula to use when calculating your burn rates. Your burn rate will be equal to the length of your SLO target in hours multiplied by the percentage of your air budget consumption that you want to know about over your long window, which will also be in hours to keep the units the same, times 100%. So if we have an SLO target window of 7 days, we multiply that by 24 hours to get that into hours. And if we want to know when a 10% air budget consumption happens, we multiply that by 10% over 1 hour times 100. And that gives us a burn rate of 16.8. Something to be cautious of is to know what the maximum burn rate is for your different SLO targets. We don't want to set an alert on a burn rate that will never trigger because it's higher than what our maximum burn rate is. To know what your maximum burn rate is, we use 1 over 1 minus the SLO target. So if you have a target of 99%, we do 1 minus 99%, all of that 1 over that. So that'll give us an actual maximum burn rate of 100. So Next, I want to talk about a few recommendations for burn rates using different targets for SLO periods and also different windows. So these examples here assume a 99.9% target, but they're reasonable for targets as low as 96%. The maximum burn rate of 96% is actually 25, and these will actually still alert on that. So in our last example, we looked at this top one, a 7-day target, where a burn rate of 16.8% over an hour will tell us about a theoretical error budget consumption of 10%. And here are a few others for like a 30-day target. A 14.4 burn rate will tell us a 2% error budget consumption over an hour or over 2 minutes and so forth. Now we've discussed burn rates, we've discussed how to define them and what they're for and how they can be used. Please do use these formulas, making sure that you check on your maximum burn rate and these recommendations as a place to start. These recommendations are from my organization, but definitely adjust them and look at other tools, including the Google SRE books section on alerting on SLOs to get started on how to use burn rates for ensuring your reliability. Thank you for joining me. If you have any questions, feel free to reach out to me at ajuna@data.hq.com, or you can tweet at me at AjunaKY. Thank you so much and have a good rest of your SLOconf. Thanks.